Very good long weekend, and you guys are raring to go to learn new things. And this is one of the new things which we are offering. So allow me, can everybody hear me? And I hope everybody can see my slides. If there's any issue, you could write in the chat. I hope everybody is able to hear, right? So today we're going to talk about digital scanning for digital manufacturing. My name is Pooja Chaturvedi. I'm the technical lead in intelligent product verification at ARTC. And as I said earlier, this is a very short webinar, and we're going to talk a little bit about the course which we'll be conducting in end of June. So today the agenda is I will do a course overview, the content, we'll talk a little bit about the benefits and the case studies. Then my colleague Louis Wong will talk about the schedule, the funding, the registration, etc. for this course. We'll take some questions from the floor and answer them regarding the course, and we'll end about 3:30. So once again, the title of this course is 3D Scanning for Digital Manufacturing. It's happening from 27th to 29th of June, 2022. It's a full 3-day course. So that's me. My name is Pooja. I'm a tech lead at ARTC. I've been working for about 25 years in image processing, automation, measurements, both looking at optical and non-optical techniques. Since I've been with ARTC last 8 years, I've been looking at optical scanners on different technologies, doing measurements, and looking at components which could be from aerospace to additive manufacturing, precision engineering, electronics. And I hold an MINT degree from NUS, Singapore, in image processing and neural networks. So that's my background. Apart from me, there will be 3 more trainers. Dr. Joseph Lifton, he's on the call with us. He's an advanced development scientist. And his main interest is X-ray CT or X-ray computed topography. He has a PhD in this topic, and he's been working for many, many years in this field on the analysis and capture itself. Then we have Rohit, he's a development engineer. Lots of hands-on experience with data acquisition and reverse engineering with the data acquired from these scanners. And he has a master's degree from NTU. Then we have Bisma, he's a senior engineer, and he has experience in 3D measurement domain for reverse engineering, segmentation, measurement, etc. He has hands-on both with the optical and the non-optical, that's the X-ray scanners at ARTC. And he has a bachelor's degree. So these are the people who have helped prepare the course and will conduct the course with me. A bit of the course overview. So what we will cover is what is 3D scanning. A lot of people talk about scanning, but what is it about? What are the different technologies for 3D scanning? What are the pros and cons? How to do data acquisition and measurement? You want to measure something very simple, you want to measure something very complex. How do you go about it with the same scanner? Reverse engineering is something getting very, very popular now. So we'll talk a little bit of how to do reverse engineering. And finally, when you come for any class or any course, you want to implement. So we will give you some tips and some advice how you will implement 3D scanning in your own industry. So what we call the LPI, learn, practice, and implement. So you will learn a lot of things in the class, theory and hands-on. You will practice, and at the end of the course, you can recommend and you should be able to implement some scanning technologies for your own applications. And the title of the course is Digital Manufacturing, and I'll touch on this a little bit later. And this 3D scanning sounds simple, is your first step to streamlining your processes for digital manufacturing. This is where the journey begins, yeah? And I'll touch a little bit more on this. So what I'm going to cover in the next few slides on these 4 or 5 big topics, some snapshots, so gives you a bit of a feel of what we'll be doing. So a bit of course content. So what is 3D scanning? 3D scanning is a process of converting a physical object, as you see on your left, it's a big metallic part, into a digital format which facilitates digitalization in manufacturing. So what you see on your right is the digital format. So the physical object becomes digital. And as I said earlier, this is your first step in digitalization. What do we do in 3D scanning? We use a 3D scanner. We look at the shape and geometry. We collect this information from various angles, and it's reconstructed into a 3D model, as you see on your right. And this 3D model can be an STL file or an STP file. So once you've converted this physical object into a digital format, there are many things you can do with it, with that information, the 3D data which you have, which I'll show you in the following slides. There are different types of scanners when you start to say, okay, I'm going to use a scanner. There are contact scanners, like the coordinate measuring machine, CMM, or the hand-driven touch probes. Those are not part of this course. In this course, we'll be looking at non-contact scanners, because this, I feel, is something which we are seeing a lot of applications in the last few years. So the first scanners which we see is the structured light scanner, which is the first image at the bottom. You see this purple blue light. So these structured light scanners, they project some light onto the object. And the way this pattern is deformed gives us information about the height. And these are the most commonly used 3D scanners for manufacturing applications. The other type of non-contact scanners, if we move away from visible light, is the industrial computer topography scanning, which is the XCT scanning. So this, we move to a non-visible wavelength, the X-ray. We use irradiation to produce information, both the external and internal representation of a scanned object. It's like taking an X-ray of yourself. When you go to an X-ray machine, you can see inside and out. It's the same for an object. And that's the image which you see in the middle. Yeah, that's the XCT of an industrial part. The third application of non-contact scanners, or a category of non-contact scanners, which we see, is something called lidar. This is light detection and ranging. And this technology uses eye-safe beams to create 3D representation of your environment. Think of autonomous navigation. You're sitting in a car and you have this lidar implant, in front of your car, and it's giving you information of your surroundings. Where are the objects? Where are the obstacles? Where you should navigate? Should you stop, etc. So in this course, we will cover the structure light scanner and the industrial computer topography scanning. So these will be the two scanners covered in this course. Moving further, now we have spoken about the scanners. What do we do with this 3D data, which is in digital format? First thing which comes to your mind is, I have the CAD of the part. Can I do some comparison? Can I see where are the areas where there are some deviations from the normal? So in the figure which you see on your left, you see some areas which are green and some areas which are orange or yellow. Green indicates everything is good, but the orange and the yellow indicate that there is some deviation from the CAD. So this helps you very quickly to look for deformation and deviations. If you go much further down, and I want to do some more analysis, some dimensional measurements, you can see we can measure diameters, we can measure lengths, so many different types of measurements in sections, in full, etc. Yeah, so that's another aspect of 3D analysis. Sometimes for parts or for things which you're manufacturing, there are no CAD drawings. They become obsolete. So with the 3D information, you can also do something called reverse engineering and make a CAD to manufacture it. So that's another application of the 3D data which you have. So we can do dimensional measurement, comparison, section analysis, first article inspection, and also reverse engineering. So this will be taught a little bit more in detail in the course. So the 3D scanning hardware, we will use the structured light scanner, which is the GOM system, which we have in ARTC. This is mounted on a robot, and you can use some hands-on time with us to learn to do very simple scanning. We also have a laser scanner, which is a roamer arm, we call it. And this is more manual, but it's based on laser. So we have optical, we have laser, and then the X-ray system from Nikon. So these are the three scanning hardware we will be using for the training itself. So once you acquire the 3D digital data, we can do some measurements. So we have some software, Polyworks or GOM-Inspect, which we can use for different analysis, as I showed you earlier. So what are the different applications? What do you do with the data? First thing which comes to your mind if you're looking for an application is quality control and inspection. I spoke about the CAD comparison, or you can do part-to-part comparison. You scan 15 parts and compare how good your output is. You can also do some reverse engineering and prototyping. Even for industrial design, you've made a first design, and then you manufacture it and then scan it, and you want to make any changes. It does help you with the design itself. Some new applications which we have seen in the last couple of years is orthodontic and prosthetic production. The image on your right, it's an image of dentures of somebody. And with the scanners, you can recreate this in digital format very, very accurately. So that's a new application. Even for production of movies and video games, including virtual reality, 3D scanners are used, though they are of lower accuracy compared to the industrial scanner, but we see a lot of use of 3D scanners there. Robotic mapping, suppose you have a robot which is programmed to follow a certain path of a free form or a simple object. You can scan the object and feed that information to the robot so that the mapping is done quite accurately. And in countries like Europe, we see digitization of cultural artifacts as another application of the 3D scanner. So they scan this whole cathedral or a church or a palace externally to recreate it. So that's another application of 3D scanning. Across industries, we see automotive, a lot of application of scanning of car doors, car bodies, comparing it, moving in. Aerospace, of course, big parts, engine parts. In construction industry, scanning facades, etc. Architecture, the same. Education, we are seeing some in the universities, etc. Your 3D printing parts, you are scanning them, etc. So we are seeing some there. Healthcare, as I spoke about, orthodontics, the entertainment industry, scanning for CGI effects, etc. 3D scanners are used. So these are the different industries. So what will your learning journey be when you come to attend this class? There'll be some teaching in the class. There'll be some hands-on session. The scanner you see first is the GOM scanner, is the structured light scanner. Then the second picture is the laser scanner, which is the handheld scanner. So we'll do some hands-on. With the 3D acquired data, we'll teach you how to do data analysis. And then you can recommend what is the most suitable 3D scanning technology you can recommend for your company or for your department, etc. So what are the benefits of this program? I see the benefits at two levels. At an individual level, you will understand the basic principles. Which scanner should I use? Should I go for the white light? Should I go for laser? Should I go for X-ray? Then when I choose the right scanner and I get the data, what are the measurements I must do? Can I do a simple reverse engineering method? What software to use? And once you do a bit of a hands-on, then you know how can I scan a simple part, a complex part, what I can get from the scanner and what I cannot get from the scanners. And then during the class itself, we're going to have some open discussion on use cases and approach. And with this knowledge to analyze and down select the most appropriate scanning solution for your application. But at a company or an application level, 3D scanning of industrial parts enables either process or product optimization, in a digitalized manufacturing environment. Suppose you've scanned something, you can send it across to your factory anywhere in the world, or your designer, wherever he's sitting, for any sort of optimization you want to do, or even in your own company, you're looking at process optimization, you change different parameters and you want to see which is the best parameter. So you can do 3D scan and do comparisons. Even with the 3D data, very simple things like visualization, you can see the object in 3D and you can quantify the geometrical changes like deformation, first article inspection, or CAD to CAM machining for production. These are different kinds of application you can implement with the data you have. Who should sign up for the course? You could be a quality manager, engineer, or a technician, or you run a process, or you're a production supervisor. And even if you're looking to upskill your staff to improve your capability in terms of advanced and digital manufacturing, it could be a very useful course in that context. So there's a little video I will play for you, which just sums up what all a 3D scanner can do and what all you will learn in this class. So what this GOM scanner is based on blue light. So we don't have to enclose the part in any black box. It works in ambient light. It's got 6 degrees of freedom. It's taking a lot of pictures of the part and it'll stitch it together to form the digital version of this physical part, which you will soon see. So you see the 3D model being reconstructed as it continues to scan different regions of the same part. And once you have the whole model, you can do measurements. And this is the full CAD model of the part, which is very accurate and repeatable. You can do CAD to part deviation, part to part deviation, section analysis, and even reverse engineering. So that's kind of sums up the capability which you will learn in this course. I pass the mic to Louis to talk about the schedule, funding, and registration now. Louis.
I'll unmute myself. Hi, thanks, Pooja. Thanks for sharing on the upcoming seminar course that we have in June, 27 to 29 of June, 3D scanning for digital manufacturing course. So this course will be held physically on the 27 June to 29, a 3-day course, as Pooja mentioned. It will be held physically at the Advanced Remanufacturing and Technology Center, ARTC. So you actually see here, we have the 2 links. First is actually the registration link, as well as the web page and registration QR codes. What we actually have here is the webinar today. If you're actually interested, you can actually go into the web page itself, the QR code, to understand more about the course itself, which is a whole 3-day course. Registration details as follows. So I just wanted to share with you on the next slide, which is actually on the course. This course, together with Skills Future Singapore SSG, we actually, ARTC provides a subsidized rate for Singaporeans to actually attend this course. As you see in the box here, the course fee after GST is $2,054. But for Singaporean citizens on the first box, second box, I would say, Singaporean citizens that are 39 years old or younger as Singapore permanent residents or long-term visit pass holders, basically they will get a 70% cost fee funding of $616. Singaporean citizens who are 40 years old and above, or those that are or Singaporean citizens, which actually are funded by small medium enterprises. You see here under the Enterprise Training Support Scheme, they will be eligible for the 90% funding support. So that means if you are a company sending your employees to this course, you will only need to pay the net fee amount. So either if you're 70% funding, either you pay the 30% or you pay the 10% course fee, which you actually see in this box. I'll also go into the next slide to actually further share with you in terms of our upcoming courses within ARTC. You see here, just to share with you, ARTC is a approved CET center by the Skills Future Singapore to provide workforce training in specialized areas of advanced manufacturing. So we focus our training on a blended training learning experience. That includes not only in the classroom, but also the workshop training. This is where our experience capabilities lie in, having actually worked with the industry, our members, on various R&D translational projects. So training as well will be held not only in the classroom, but also in the laboratories, which we saw actually at the GOM video, a short clip which trainer Pooja has shared. The GOM was actually in one of the workshops in the RTC as well. I'm sure you'll get opportunity to gain first-hand experience to have a look at these various technologies. So the 3D scanning for digital manufacturing course is under one of the courses under the digitalization team. You see in the green box, ARTC has organized a range of other courses throughout the year. You see here in 4 different teams, not only in the digitalization, but also advanced manufacturing processes. You look at various direct deposition or even 3D printing technologies. Also on the robotics, as well as the electrification related courses. Yeah, so you're welcome to have a look at not only the QR code, which brings you to the website of the 3D scanning course itself, but the other range of courses that ARTC has actually organized. Yeah. So thank you for your time. Maybe we can actually open the floor out to any questions that you may have for the trainer.
Thank you so much, Louis. While we are doing the Q&A, I would actually like to launch a poll to understand the interest of the participants here today. So do take some time to answer this poll. And I believe there's some questions for you, Louis. Here, let's go ahead and Q&A.
Okay, we'll just go ahead with the Q&A now. Okay, so one of the questions are, what are the accuracy of 3D scanners? And what are the smallest and biggest parts you can scan?
Louis can answer that.
Oh, sure.
Okay, I'll take that question. Louis, have you muted? Yeah, thank you, Louis. For the biggest to smallest part, for optical scanners, we can scan up to a few meters, though we see parts which are a few tens of centimeters mostly. Also, the range for the scanners depends whether it's mounted on a robot, it's handheld. So for a few meters, that's the biggest size we see. For the smallest one, Joseph, few cms is always possible, few with the XCT scanners.
Yeah, for X-ray CT, we can scan very small parts, millimeters, with resolutions of nanometers, or we can scan up to quite large parts, around 80 centimeters in diameter and 80 centimeters in height. We also have in-house developed capabilities that allow us to scan very long objects like tubes. So we can accommodate a lot of different sizes and shapes of objects using X-ray CT scanning.
Thanks, Joseph. And that goes for optical scanners also, different shapes, sizes, surface finishes. We've scanned parts which are very reflective or which are very dark, possible. Speaking of accuracies, actually accuracies is very difficult to pinpoint for the whole industry itself, but for the top-end optical scanners, 10 to 20 to 30 micron accuracies are possible in laboratory conditions, depending on which features you are trying to measure, what's the surface finish like. But as Joseph mentioned earlier, the accuracies could improve with higher resolution for XCT scanners is possible. So the range is few to few meters and accuracies from few microns to tens of microns. That's the scanning which we are seeing. I saw some questions in the Q&A. Do you think, okay, should I take the first question? What's the difference between 3D scanning and 3D printing? A very interesting question. Huh? It sounds so similar. So 3D scanning, as I explained earlier, you convert a physical object into a digital format. You have a CAD file or an STL file. In 3D printing, you have the CAD, you have the digital format, and you convert it into a physical object. So you actually print it and you have a 3D part yourself. So they are the reverse of each other. Yeah. So I hope I've answered your question. Shanmugan Krishnamurthy, I will take your question. How about 3D printing related to construction industry? Does ARTC provide any training on it? There are some 3D training courses. Luis, you want to answer that? Maybe they can go to our website.
Luis, you're on mute.
Yeah, sorry, I was on mute. Yeah, so for 3D printing, we have two different types of 3D printing courses, utilizing two different technologies. One is actually on the powder bed related technologies. One is on the laser blown related technologies. So do feel free to have a look at our website to understand. I believe our 3D printing course, the one upcoming is on the powder bed, the additive manufacturing for practitioners. That will be held sometime in June. So please feel free to have a look. We have actually recently organized a webinar for this course as well, which has been uploaded into the website. Thank you.
There's another question. Is it possible to scan internal profiles? Yes, it is possible to scan internal profile using the
Pooja, we can't hear you. Are you on mute?
While Pooja unmutes herself, I'll answer that question. We've had one come in. I'm not sure if everybody can see it. It says, possible to scan internal profile. Some parts got to section it in order to check the internal profile. Excellent question. This is the whole point of using X-ray computed tomography. It allows us to scan inside the part for exactly this purpose. So instead of chopping the part open or sectioning it in order to measure the inside, we can use X-ray CT, which will give us the full 3D internal and external information. So we've been developing internal surface roughness measurement capability and internal dimensional measurement capability. So if you have problems like this, then we can discuss that as part of this course, or you can contact us if you're looking for a measurement service to solve that. Thank you.
Right. Thank you so much, Joseph. Right, so we have more questions, Pooja. I think I see everything Louis' laptop. All right, we have a question from Mr. Shamugan asking if it would be useful to take 3D scanning and printing course.
Yes, it would be useful to take both the courses, depending on the application you would like to have. For facade, for construction industry, I assume you're coming from there. We see a lot of scanners being used for external, and to understand a little bit more on the scanning technology and what you can do with it, I think this would be a useful course as a first step.
All right, thank you, Pooja. I think we have more questions coming up. So the nominalist participant is asking, will CT scan be able to capture internal channels, such as cooling channels or parts of internal profiles? Are there any limitations?
I'll take this one. Yes, we can do that. We're doing a lot of that at the moment. Internal channel surface roughness is of interest to a lot of manufacturing industries, as well as internal channel dimensional measurements. We've developed capability in this area using X-ray CT. What are the limitations? The limitations are based on the material. If the material is very dense, something like Inconel, a high density metal, then that becomes difficult because we need to penetrate the metal using our X-rays. If it's a lighter material, lighter metals, aluminiums, titaniums, no problem. Polymers also no problem. So the limitation is really material density and thickness, as well as resolution. Spatial resolution. If we're scanning very big parts, then sometimes it's difficult to scan with sufficient resolution. So if you can provide more information on the measurement problem, then we can give a more detailed answer. But in general, yes, that's possible.
Right, thank you so much. I think the question.
Could I take the next one, Tom?
Yeah, go ahead.
What precautions should be taken for safety during handheld scanning? Our handheld scanner is laser based, but is in few milliwatts. It's a class 2 laser scanner. So there is no requirement from the manufacturer itself, but as a user, as the RA and SWP, when you are scanning and you're pointing the laser towards the object, it's better to keep the rest of the team, or if anybody's working around, not to be in that area, or it reflects back into the person, into the eye. So the power is very small. There is not much safety, but one thing you should keep in mind with the handheld scanners is the ergonomics. The person who's scanning, and if it's a very large part, and he's going to do it day in and day out, there might be some ergonomic issues with these scanners. So all depends on the source. If it's an optical thing on a handheld scanner, then there's no issue with scanning itself. Can we scan non-metallic pipes? Yes, we can scan non-metallic pipes. We've done some plastic pipes or some other material to see the deformation. Yes, you can compare with the CAD and see the deformation, or if you're comparing two different pipes, we can also do a part-to-part comparison. Okay, let me read this question. Since we have some failure of GRP, always think of 3D scanning. I know I spoke about like 3D scanning will solve all your problems. If you use an optical source, you're getting only the external scan of the part. If you use an XCT, you can get internal structures. So when you have an application, think whether you're looking at internal or external. And as Joseph mentioned, there are limitations on the size of the material through which the X-ray can penetrate. So if you have more specific queries, you could drop me or Joseph an email. My email is on the brochure itself. You could drop me an email and we could discuss this.
I'll just respond to that one as well, Pooja. So the question seems to be about glass fiber reinforced pipes. And to avoid destructive testing, i.e. chopping the pipe open to look at the internal deviations or damage or deformation, yes, we can use X-ray imaging to do that. We can either look at it in a typical radiographic manner, where we just create one X-ray image, which will show you a bit of information, or we can do a CT scan where you'll get the full 3D information, both internal and external. So if you're looking for damage or deformation in those pipes, then yes, that will be possible.
This course is for beginners. We're going to teach you from the beginning. And if you have some background on 3D scanning, you can do the more advanced parts with it.